Hello guys, very good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, the BYJU'S Exam Prep, and yes, I Rakesh Talreja welcome you all to the BARC HAL 2022 Atomic series. Yes guys, so as you know, we have been conducting the sessions for BARC and HAL from quite some days. I already took up the lecture number 1 of electromagnetic theory, and today is the time for lecture number 2, where we go on to study some more important topics. Yes, so quickly confirm everybody, is the audio fine? Is the audio fine to everybody, so that we can begin up this revision of electromagnetic theory in the second part? First part we focused on the concepts based on electrostats, magnetostats, basic waves and all those things we focused in the first lecture. We'll take a few more concepts today. Yes guys? Yeah. Okay, yes, it's audible. I'm getting the comments, so I think it's good to go to start then. Okay, so quickly update your friends, share the session and inform everybody that the session is now live, so that everybody can gain for this BARC and HAL preparation. Okay, hello, hi, good evening everyone, keep joining. Chalo, so begin karte hain guys. This is a brief intro about me, in some case somebody new to the session. This is your mentor and educator Rakesh. I have secured all India rank 9th in the GATE examination, completed my masters from the Indian Institute of Science Bangalore, and trained more than 50,000 students in my 11 plus years of journey. I majorly deal with the technical areas of control system, digital electronics, EMT, signal and system, and I also deal with the engineering, mathematics and aptitude portions. Yes guys, good evening. Yes guys, so as I keep sharing the PDF of the session, I shared it for the control systems also, signal systems also, and yes, for EMFT also I will do share up the session, the PDFs of both the sessions. One of the sessions I took day before yesterday. Today is the second lecture of electromagnetic theory. To get the PDF, to get more updates about the classes, to have the doubt discussions, you can join this group GATE/ESE by Rakesh Talreja. Right. Also guys, a quick update for those who are planning to appear for the GATE 23, GATE 24, that is the upcoming GATE or engineering services examination, or your friends or juniors might be interested, you can update that yes, the BYJU'S Exam Prep GATE YouTube channel, the channel where you are watching this class, bringing you the series Mastering GATE Concepts, where you get the complete subject analysis, the conceptual clarity for the most important concepts of that subject in detailed concept clarity, so that you understand in the best possible manner, and supported by problem practice and previous year questions also, so that you get an idea how deep a GATE goes into that particular concepts, and then to be terminated by live Menti quizzes. Yes guys, to make it interactive, to make it fun guys, in the end we'll also add up the Menti quizzes on the YouTube. Acha ji, right? Let's talk about the schedule. This is what is the schedule. Since you guys are electronics, EMT class, electronics ke students hain aaj class mein, so you can note that since today is Thursday, so you will have a network theory class by Sanjay Rathi sir at 10:30 p.m. and it will keep on happening on these specified days. Okay, after network they will, and this will keep on going. This is one subject network. After that, you'll get another subject, suppose signals or something like that you are going to get. Okay guys, those who want a detailed preparation strategy, okay, to conquer GATE 23 by one of your favorite Abhinav Negi sir, who is an alumni of IIT Delhi, senior faculty at BYJU'S Exam Prep, and more than 10 plus years of teaching experience, will be taking up a workshop. This is not on YouTube, but this is a workshop on the app. Okay, that is on Sunday 13 March 12:30 p.m. Okay guys. Okay, so yes, many of the aspirants and students keep asking me about the doubt regarding time management, especially those who are college goers. how can you balance the gate preparation and college routine, right? If you also have such a dilemma, if you also have such a doubt, okay, join me live to talk about the time management funda, how to handle both college and gate preparation routine. And join me live this Saturday. Join me live this Saturday, that is 12th of March, right? As you know, every Saturday we are bringing you some of the important concepts Saturday, and also some of the weekdays also we are bringing you important guidance for the preparation. So time management is a very, very important fundamental, and this goes live at the 9:30 p.m. Okay, acha ji. Okay guys, so guys, first question for today. Now let us get started with the question. A lossless transmission line has a characteristic impedance of 100 ohms and impedance per unit length of 1 microhenry per meter. If the line is operated at 1 gigahertz, what is the propagation constant beta? It's a lossless line, right? For a lossless line, the alpha is 0, the attenuation constant is 0, and beta is given by the formula omega root over LC, isn't it? Okay, so we can just directly apply this formula. So the beta, the propagation constant beta will be the propagation constant, or commonly known as the phase constant actually, will be given by the formula omega. Now how much is the omega? Omega is 2 pi into f. F is 1 gigahertz. This is the omega into under root of LC. What is the L? Is 1 microhenry per meter, 1 into 10 power minus 6, and C is not given to me. Acha ji, sorry. C is not given to me. So what is given to me actually? The impedance of the line. What is the impedance of the line? Z0. It is given by the formula root over L by C. For lossless line, it is given by the formula root over L by C. So we don't require the value of C. And there is one thing, Z0 is given, L is given, you can find out the value of C. But no need. What you can do is simply multiply them. Multiplying them, beta into Z0 will become omega, root L into root L will be L, C and C cancel. So beta Z0 is equal to omega into L, right? Beta into Z0 which is equal to 100 is equal to omega, which is 2 pi f, 2 pi f, right, into the value of L, which is 1 microhenry per meter. That's it. From here you get the value of the beta. Very simple question, then very simple calculation also. Beta, this is 10 power 3 divided by 100, so 20 pi. What is going to be the answer is 20 pi, and beta is measured in radian per meter. 20 pi. Correct guys, C, 20 pi is the very correct answer for the question. Moving ahead to the next one. The propagation constant of a lossy transmission line. The question says that this is a lossy transmission line. The propagation constant gamma is 2 plus J5. 2 plus J5, and its characteristic impedance is 50 plus J0. Its characteristic impedance is 50 plus J0. Z0 is 50 plus J0, that is effectively 50, and Z0 is purely real. Now whenever the Z0 is real for a lossless line, what you should note that for a for a transmission line, whenever the impedance is real, it may be lossless or it may be distortionless. Lossless to nahi ho sakta because it's specified as lossy, and you can even see this is known as the alpha, this is known as the beta. Alpha is non-zero. Alpha is non-zero. So whenever Z0 is real, the line may be lossless or the line may be lossy but distortionless. Okay, the line may be lossless or distortionless. That may be the case. Acha ji. Right. Now, if the line is lossless, alpha should be 0. If the line is distortionless, alpha does not equal to 0. Actually, alpha is given by the formula square root of Rg. Square root of Rg. Right. Now, so definitely alpha is not equal to 0. It is a distortionless line whose alpha and beta is given to me. Omega operating frequency is given. What is the value of the RLGC? LC, RG. चारों का value निकालना है. So once again guys, since it's a distortionless case, है. So what is the formula for alpha? I am telling under root of Rg. Right. What is the formula for beta? Beta formula is actually same, omega root over LC. The Z0 formula, so for the distortionless line, there are the two formulas for Z0. It is either root R by G or root over L by C. This one is same, okay, this one is same as the lossless line, but what is the condition for distortionless line? R by L is equal to G by C. So when you take L by C, it is also equal to R by G. So I can write down the two different formula for the impedance of the line. Okay. Now number one thing क्या करेंगे? Just multiply alpha and Z0. Alpha and Z0. Which formula? First formula of Z0 you multiply. So G and G getting cancelled. Root R into root R is equal to the R. Okay. So alpha into Z0 is equal to the R. अच्छा जी. Alpha into Z0 is equal to the R. So what is the value of the alpha? Alpha is 2, Z0 is 50 is equal to R, and hence you get the value of the R, that is the 100 ohm per meter. 100 ohm per meter. So the value of R is 100 ohm per meter, right? So that leads to option B or C, right? Now from here only if you get the value of G, अब देखो alpha को use कर लेंगे, alpha is square root of RG, alpha का value मुझे पता है, so I have alpha square is equal to R into G, and hence the value of G becomes alpha square. Alpha is equal to 2, so 2 square divided by the value of R, which is 100, 4 by 100, 0.04, and Siemens per meter. 0.04 Siemens per meter. So G should be 0.04 Siemens per meter. So the C is wrong. Option number B. No need to calculate L and C. Your option is matched here. Your answer is matched. That is the option number B. Okay guys, the correct answer to the question is option number B. Option number B, right? So by these two, just by these two, I'm combinedly telling that option is B. No need to calculate L and C. Okay, yeah, if you want to calculate L and C, then you have to use the beta formula and the second formula of Z0. You'll get LC also because omega is given to you, but that is actually not required for us. Okay, actually not required. Next question, guys. A lossless line having the characteristic impedance Z0 is terminated with a load impedance of JZ0. What is the VSWR of the line? A lossless transmission line having the characteristic impedance Z0 is terminated with the load impedance JZ0. What is the VSWR of the line? Okay, so what is the VSWR formula? VSWRs is given by the formula 1 plus modulus of K divided by 1 minus modulus of K, KL, the load reflection coefficient. Right? Now, what should be the value of KL? KL is given by the formula ZL minus Z0 divided by ZL plus Z0. These are some of the most expected and important type of questions for this government based examinations. ZL minus Z0 upon ZL plus Z0. ZL is JZ0, then minus Z0 divided by the JZ0 plus Z0. So you are able to see that Z0 is common and can be cancelled. So you have J minus 1 upon J plus 1. But eventually you need the value of mod K. What is KL? Actually minus 1 plus J upon 1 plus J, but you need the value of modulus of KL, and modulus of KL is square root of 1 square plus 1 square, again divided by square root of x square plus y square, and the modulus of KL is equal to the 1, and since the modulus of KL is equal to 1, so this becomes 1 plus 1 upon 1 minus 1 tending to infinity. So the standing wave ratio will be option number C, infinite, correctly stated by some of the students in the comment box also. Option number C. The correct answer is option number C. Yes. And what I am able to see that coming, as the classes go on, okay, the energy, the motivation of the students little bit go down. I am able to see less attendance today in the class, guys. Yes. Are we motivated enough for the BARC and HAL preparation? Or, we are simply making the sessions and students are not much interested at this point of time, guys? What it is? So correct answer is option number C, that is infinite. Moving ahead to the next question. When a load resistance RL is connected to a lossless transmission line of characteristic impedance 75, it results in VSWR of 2. VSWR of 2. What is a load resistance? देखो, load resistance is also given to you as RL. देखो, ध्यान रखना, there is a trick. I have discussed that trick earlier also. When both ZL and Z0, okay, when both ZL and Z0 are real, okay, that is ZL is equal to RL and Z0 is equal to the R0 when both the resistance are real. Real means resistive. Real load means resistive. When both the impedances are resistive, then the VSWR, voltage standing wave ratio, see, for voltage standing wave ratio normally we find K first. Okay, 1 plus mod K upon 1 minus mod K, okay, is the standing wave ratio, and then you have to find the value of KL as ZL minus Z0 upon ZL plus Z0. It's a two-step calculation, but when both the resistance are real, you can make it into a single step, very simple calculation, that S is basically given by the formula ratio of the resistance RL by R0, or it may be R0 divided by RL, any one of them. RL by R0 or R0 divided by the RL. The first formula will apply if RL is greater than R0. The second formula will apply if R0 is greater than RL. To be very simple, because we know that standing wave ratio is always greater than 1. Standing wave ratio range is given by 1 to infinity. It is always greater than or equal to 1. So that is why the numerator should be greater than denominator. So simply remember, it is the ratio of both the resistance. Whichever is the greater one, that should be there in the numerator part. अच्छा जी, okay, तो निकाल लेते हैं हम आंसर. Okay, let's keep moving ahead. Okay, so what is the answer then? VSWR is equal to 2 is given. Now here actually RL is unknown, so I don't know which is greater. I can try the possibility. RL divided by R0. R0 कितना है? 75, or it may be the R0 divided by RL. Okay, so RL can be equal to how much? If I use the first formula, it is 150 ohms, or if I use the second formula, 75 by 2, it is going to be the 37.5 ohms. Right, 150 or 37.5 ohm. So only possible option that is matching here is option number D. Right, suppose if both are there in the option, then they will actually give you some more data to support, okay, that whether RL greater than R0 or RL less than R0, something will be mentioned, don't worry. Here it is the option number D. 37.5 is not in the option. Okay, moving ahead to the agla question. VSWR of a microwave unit is 1.5. What is the return loss? What is the formula for return loss? What is the formula for the return loss given by? The return loss is given by the formula minus 20 log of mod KL. Right. Correct, Surajit. If there is a maxima at the load, then RL will be greater than R0. KL is positive, real number. Okay, so RL is equal to the minus 20 log mod KL. Minus 20 log mod KL. Right, so from this VSWR, okay, VSWR is 1.5, standing wave ratio is 1.5, which is given by the formula 1 plus mod KL upon 1 minus mod KL. Find the value of mod KL, or directly, okay, or directly when you simplify, because this is also a very common calculation. Given standing wave, find the value of mod KL. So mod KL will be S minus 1 divided by S plus 1. That is also a separate formula that you must know. S minus 1 divided by S plus 1. So what should be mod KL here? S kitna hai? 1.5. VSWR 1.5. So 1.5 minus 1 upon 1.5 plus 1, that is 0.5 upon 2.5. 0.2. 1 by 5 it is turning out to be. It is 1 by 5 after cancellation. So what is the return loss? It is given by, sir, minus 20 log 1 by 5. Log 1 by x is minus log x, so minus cancel karte hue 20 log 5. Right, what should be 20 log 5? 20 minus 6, approximately 14 decibel. Approximately 14 decibel is the option number A is the correct answer. Right. Yes, Rajdat. Correct answer, guys. It is the 14 dB. 14 dB is the very correct answer for this question. अच्छा जी, next question की तरफ जाते हैं. The parallel branches of a two-wire transmission line are terminated in 100 and 200 ohm resistors as shown in the figure. Okay. The characteristic impedance of the line is Z0 equal to 50 ohms, and each section has a length of lambda by 4. Find the input impedance. Find the input impedance. So the parallel branches of a 2-wire transmission line. Okay, so solve karte hain isko. It's a simple question only. The parallel branches of a 2-wire transmission line are terminated in 100. So these are the two parallel sections given to you. One of them is terminated in 100. Another one is terminated in 200. As shown in the figure, the characteristic impedance of the line is 50 and each line has a length of lambda by 4. Okay, each line has a length of lambda by 4. So whenever guys the length of a transmission line is lambda by 4, what is the input impedance? Very, very important formula. The input impedance, very important formula, is given by Z0 square divided by the ZL. It is given by the formula Z0 square is divided by ZL. Z0 square is divided by the ZL. Okay. Chalo. So what I am going to do, guys, okay, we are going to calculate the input impedance of both these parallel sections. Suppose that is known as the Zin1 and this is known as the Zin2, so that we can replace the transmission line by its equivalent input impedance. What should be the value of Zin1? Zin1 will be given by the formula Z0 square, that is 50 square divided by 100. So ye 25 dikh raha hai. What should be the Zin2? It is given by the formula 50 square divided by 200. Right, so this is 25, uska bhi half, 25 divided by the 2. Right, so now what is the equivalent picture corresponding to this? What is the equivalent picture? You have the main transmission line which was terminated by two parallel transmission lines. Okay, and I have found out the equivalent input impedance of both the lines. Okay, Zin1, this one is 25, Zin2, this one is 25 divided by 2. Right, this line has the impedance of 50 ohm and this also has the length of lambda by 4. Question is asking what is the input impedance of the overall section. Okay, what is the input impedance, final input impedance here of the overall section? This is what is the question. So this input impedance, because again it is having the length of lambda by 4, the formula will be Z0 square divided by the ZL. So sir, Z0 is 50 square divided by ZL. So what is the value of the ZL? What should be the value of ZL? What should be the value for the ZL? So now it is 25 in parallel. Zin1 is parallel with Zin2 to form the overall load impedance. So 25 parallel 25 by 2. So R parallel R by 2 is R by 3. Directly you can use the formula. So R parallel R by 2 is the R by 3. So yahan pe aa jayega R by 3. That is the 25 divided by 3. 25 divided by 3. So kitna hua? This is cancelled as 2i. So 50 into 200, 100 into 3. 300 ohm should be the final answer, guys. 300 ohms is the answer. The input impedance of the line is equal to the 300 ohms. The input impedance of the line is the 300 ohms. Okay, chalo, all cool. Moving ahead to the next question. In the circuit shown, all the transmission line sections are lossless. What is the voltage standing wave ratio on the 60 ohm line? Once again, circuit consisting of transmission lines which may be in parallel or series, we need to check. All the transmission lines are lossless. What is the VSWR on the 60 ohm line? What is the standing wave ratio on this line? So guys, once again see now, this line is first terminated by a short circuited line of length lambda by 8. Okay, so let us first calculate the input impedance of this one, Zn1. Then followed by means in series. Okay, there is another line of length lambda by 4 and terminated with the load 30. Okay, so let us say the impedance seen here is the Zn2. First calculate both of them. So what should be the Zn2? Because it is lambda by 4 again. It is the length lambda by 4, so it is given by the Z0 square. 30 root 2 whole square divided by the ZL, that is 30 cancel, 30 into 2 60. So this part is the 60 ohm. What should be the Zn1? Zn1 yahan pe nikal lenge. Zn1 is actually ZSC, input impedance of a short circuited line, guys. Input impedance of a short circuited line. And what is the formula for input impedance of a short circuited line? The input impedance of a short circuited line, lossless line, is given by the JZ0 tan beta L. So this is going to become J, ये Z0 30 है, okay, this value is the 30. Okay, so J into 30 into tan beta L, beta is given by the formula 2 pi by lambda and length is given in terms of lambda, that is the lambda by 8. That is the lambda by 8. Okay, so lambda cancel, 2 pi by 8 will be pi by 4. So this becomes tan pi by 4 is 1. So answer is J30 ohms. What should be the Zn1? So Zn1 is given by the J30 ohms. The Zn1 is given by the formula, that is the J30 ohms. Okay, J30 ohms. Okay, so now once again guys, what is the equivalent picture that you are able to draw here? Okay, so you have the main line, that is the 60 ohm line, onto which you need to calculate VSWR. It is first terminated by the short circuited line whose final impedance is J30. J30 means inductive, positive imaginary number, no? So that is the inductive, positive reactance. And now Zn2, then followed by Zn2, which is real. So that is equal to 60 ohms, this part. This is Zn1, which is equal to J30 ohms. That is why I am showing it as an inductor. So there will be a final load value. This is known as the load of the main line. This will become the ZL. You need to calculate the standing wave ratio here for the line whose impedance Z0 is equal to 60 ohms. Okay, whose Z0 is equal to the 60 ohms. So what should be the value of the ZL first of all? Here the ZL, it is a series combination of the two impedance and hence it will be added J30 plus 60 or 60 plus J30, correct? So what should be the load impedance? It is the 60 plus J30 guys. Acha. Okay, now ZL is known, so you will calculate the KL, that is ZL minus Z0 divided by ZL plus Z0. Okay, and that is given by ZL is 60 plus J30 minus Z0. Z0 is also 60 here, divided by 60 plus J30 plus 60. So 60 getting cancelled, J30 upon 120 plus J30 and 30 cancel karte hue, J is divided by 4 plus J. So what should be the value of mod KL? Mod KL, magnitude of KL is given by 1 upon square root of 4 square plus 1 square. 1 is divided by under root of 17. Then the standing wave ratio is given by the formula 1 plus mod KL upon 1 minus mod KL. Evaluate the mod KL, put down the value here या directly यहीं पे put करें 1 plus 1 by root 17 upon 1 minus 1 by root 17 and that is equal to the root 17 plus 1 divided by root 17 minus 1. Solving it, you are approximately going to get the value of 1.64. 1.64, that is the option number B. Approximately you are going to get the correct answer. Okay, the option number B is going to be the correct answer for this. Acha ji, moving ahead to the next question then. Right, yeah, before I move to the next question, this is the information I already updated. You know, those who are worried about time management for GATE exam, especially with college. So you can join me live on this Saturday 9:30 p.m. on the same channel. Do not forget to subscribe it. Saturday 9:30 p.m. Okay, next question guys. The radiation resistance of a thin line center fed lambda by 2 antenna with sinusoid current distribution is how one. This is a factual question guys. Okay, for lambda by 2 dipole, what is the radiation resistance? That is the value that must be known to you. It is given by what? It is given by the 73 ohm. Radiation resistance, not the total impedance they are asking. It is given by the 73 ohm, correct? Okay, for lambda by 4 monopole, quarter wave monopole. Okay, for the quarter wave monopole, the radiation resistance is given by the half of the above value, right? That is 36.5 ohm. 36.5 ohms, right? So these are the values which must be known to you. Next, if it is a Hertzian dipole, let us revise these important formula. If it is the Hertz dipole, acha, what is the Hertz dipole? Whose length is less than or equal to lambda by 10, a very small current element, length less than equal to lambda by 10, then the radiation resistance is given by what formula? It is given by the formula 80 pi square dl by lambda. Dl means the small length of the antenna. Since it is very small, we call it as dl by lambda whole square. So 80 pi square dl by lambda whole square. It is given by the formula 80 pi square dl by lambda whole square. The 80 pi square dl by lambda whole square. Okay. Right. If it is the Hertz monopole, then base fed Hertzian monopole, then the radiation resistance, again the half of the above one, that will become 40 pi square dl by lambda whole square. Okay. An antenna has a radiation resistance of 72 ohm, loss resistance of 8 and a power gain of 16. Calculate its directivity. Power gain and directivity. Dekho. So what is the formula for radiation efficiency? What is the formula for the radiation efficiency? The formula for the radiation efficiency is given by Gp divided by D, where Gp is known as the power gain and D is the directivity. This is known as the power gain, which is given to you. Okay, and then D is the directivity, that is what you want to calculate. Okay, then how do you calculate radiation efficiency? There is one more formula. Okay. Radiation efficiency, one more formula, that is given by the radiation resistance. Yeah, I can also say it is also given by the formula P rad upon P in. The total power radiated by the antenna divided by the total power that is input to the antenna. Then this is given by the formula P rad upon the total power input to the antenna is a part of it is radiated and a part of it is lost due to the conductors of the antenna, and putting the P is equal to half I square R, you eventually get the formula R rad is divided by the R rad plus RL. This is the another formula that you can use. Okay, so let us use both of them and conclude the answer. So what is the answer? Radiation resistance is given to you and loss resistance is given to you. Let us use the formula R rad upon R rad plus RL. What is the radiation resistance? Radiation resistance ho gaya 72 is divided by the 72 plus 8, and that is 72 divided by 80 or 0.9 is the radiation efficiency. So radiation efficiency, which is also given by the Gp divided by D, and the D will then be given by power gain, which is 16 divided by 0.9. Solve it up, near about 17.77 is the directivity you will get. That is the option number C. 17.77, that is the option number C. Okay, correct answer is the option number C. Okay. Yeah. A very simple question. The electric field measured in the far field of an antenna at a distance of 50 meter is 1 volt. What is the average power density at a distance of 500 meter? First distance 50 meter per 1 volt. So no, because it is the question, because it is the electric field calculation in the far field. In the far field, we know electric field is proportional to 1 by R. It is just inversely proportional to the distance from the source, so that I can write down the E2 divided by E1 is given by the R1 divided by R2. Right. So E2 divided by E1, the first field is 1, is equal to R1, that is equal to 50, and the second is 500. So what should be the value for E2? E2 is given by 1 by 10, that is 0.1 volt per meter. Right. Now you want the average power density. Average power density means the time average power density. The time average power density associated will be given by what formula? Okay, mod E square divided by 2 eta. So this becomes mod E 0.1 whole square divided by 2 eta. What is the eta for free space? Impedance of the free space is 377 ohms. Right. Yes, correct. Solve it up. Okay, calculations I leave up to you. Solve it up. You are approximately going to get 13.3 microwatt per square meter as the answer. Okay, power density, power watt per meter square में calculate होता है. Yes, correct guys. Surajit are correct. Option number D is the very correct option. 13.3 microwatt per square meter is the correct answer. Okay, moving ahead to the next question. Chalo. An antenna with the efficiency of 90%, has maximum radiation intensity of 0.5 watt per steradian. Calculate the directive gain of the antenna when the input power to the antenna is 0.4 watt. Directive gain of the antenna when the input power to the antenna is 0.4 watt. Right. So efficiency is given and input power is given. So number one thing is clear. I can calculate the radiated power. Okay. Then maximum radiation intensity is given to you. So see guys, what is the formula for the directive gain? Okay. What is the formula for the directive gain? So few more important formulas will come up here. The directive gain GD is given by the radiation intensity of the antenna divided by the average radiation intensity. Okay, divided by the average radiation intensity. Now this is one of the formula where U is known as what? U is the radiation intensity. Okay, acha. Then GD is given by the formula U. What is the formula for average radiation intensity? It is given by the formula radiated power upon 4 pi. So it ultimately becomes 4 pi U divided by P rad. Right. 4 pi U divided by P rad. So this question should actually be, they have given the maximum radiation intensity. The question should be find the directivity, because since the radiation intensity is maximized, the directive gain will also be maximized. And what is the maximum directive gain? The maximum directive gain is known as the directivity, right? So directivity, which is the GD max, will become how much? Will become 4 pi U max upon P rad. Okay, now let us calculate. So the directivity will become 4 pi U max upon P rad. Now how do you calculate P rad? We know that P rad upon P, just now I defined, it is known as the radiation intensity of the antenna, that is the eta R, right? So what is the radiated power? It is known as the radiation intensity into the power that is input to the antenna. Now this data is given to me. 4 pi U max 0.5 watt per steradian divided by efficiency 90%, I think 90%, 90 correct, and multiplied by the input power is 0.4, right? Just complete the calculation and get hold of the answer, right? Just complete the calculation. So this is what, this is numerator is 2 pi divided by 0.36 correct, divided by the 0.36. So calculate this value. Just let me check what is the value coming up finally. Yeah, 17.45. 17.45. Option number B is the correct answer. 17.45. Option number B is the correct answer. Okay, moving ahead to the agla question. Okay guys, 17.45 correct answer. Acha, one more thing let me mention here. Okay, just sorry. Okay. So I wrote one more formula here. GD is equal to 4 pi U by P rad. GD, which was U upon U average, we have written that formula as 4 pi U upon P rad. One more formula which can be important for you is 4 pi. Now what is the U? What is the U given by? The radiation intensity is given by the formula R square into time average power density. R square into time average power density, right? Rakesh, daily actually, whenever I took the earlier classes also for digital and EMT and control, 8 p.m. we are starting the bar class, na Rakesh? Right. Okay, so U का value put किया तो 4 pi R square P average divided by P rad. Also this formula you must know. Sometimes you can expect the question on this one also. The radiation intensity of an antenna is given to you, 2 sin theta sin phi, which is in the range theta 0 to pi and phi also 0 to pi, and otherwise it is 0. What is the directivity of the antenna? Now see very carefully what you need to calculate. You need to calculate the directivity of the antenna. Just now we discussed what is the directivity? GD max. GD max is given by what formula? GD max is given by the formula 4 pi U max. 4 pi U की जगह 4 pi U max upon radiated power. So there are the two things you need to calculate: U max upon P rad, right? U max upon P rad. Now U is given to you as 2 sin theta sin phi. So sir, what should be the value of U max? What is the maximum value of sin theta? That occurs at theta equal to pi by 2 and then phi equal to pi by 2. Both are in the given range. The range is 0 to pi. So sin theta maximum value 1, sin phi maximum value 1. So U pi, U max का value तो 2 आ गया. So that is not a problem. I need to calculate the radiated power. I need to calculate the radiated power. Now just now I was telling you. Now radiated power कैसे निकालना है? P rad. What is the power that is radiated by the antenna? That is given by the formula surface integral of, understand some more terms, surface integral of the time average Poynting vector, the time average power density, P average dot ds. Now this is basically given by the formula. When you open up the ds, see, it becomes r square sin theta d theta d phi. In the spherical coordinate system, the ds along the radial direction, because the Poynting vector is in the radial direction, the direction of propagation of wave. So the ds is given by r square sin theta d phi. Now out of this quantity, guys, out of this, the term P average into r square, this is what is known as the radiation intensity. This is what is known as the radiation intensity we just defined. So what is the power radiated by the antenna? It is given by double integral of U, which is given to you, into sin theta d phi. Sin theta d phi. Okay, that is what you need to calculate here. Okay, ये निकालना है यहाँ पे. तो चलिए, let us start evaluating. So what is the radiated power? That is given by double integral of 2 sin theta sin phi, that is the value for U given, sin theta sin phi, multiplied by one more sin theta d phi. Clearly the variables are separable, so better to separate the integration and do it up easily. So 2 is just outside, constant hai, sin theta, so that is the integration of sin square theta d theta. Next is the integral sin phi d phi, right? Okay, the limit for theta is 0 to pi, the limit for phi is also 0 to pi. So this becomes 2. The integral of sin square theta, that is directly as solved by Wally's theorem. I have explained earlier also. You must know Wally's theorem if you want to be quick in the integral calculation for trigonometric function. Wally's integral formula. So sin square theta के लिए answer हो जाएगा 1 divided by 2 into pi by 2, right? And for sin phi के लिए it is simply minus of cos phi, and that will again become, this is 0 se pi. 1 second guys, this is 0 to pi, so first I have to convert this into 0 se 2 pi, twice integral 0 se pi by 2 sin square theta d theta, right, into once again twice integral 0 se pi by 2. नहीं, इसके लिए ज़रूरत नहीं है, this you can do directly also, that's not a big deal. 0 se pi, because that is a sin power 1 case only, na, sin phi d phi. So now this will become 4 into 1 by 2 into pi by 2, right, multiplied by 1 by 2, yeah, multiplied by 1 only, that is going to be 1, na? Sorry, that is actually going to be 2, minus of cos phi, and then cos phi and cos 0 are both 1, so ये आ जाएगा 2. So 4 cancel, this answer is coming out to be 2 pi, right, coming out to be 2 pi. So, I hope you are able to understand this integral, because I'm not, going into the detail of explaining the integration here. That can be taken, that can be assumed from my side. So, what is the directivity formula I have written? The directivity is given by the formula 4 pi u max upon p rad. Now we have calculated most of the things. 4 pi u max, देखो u max निकाला था, u max का value है 2, divided by the radiated power, that is the 2 pi. That is known as the 2 pi. So the answer is equal to the 4. Answer is equal to the 4. Right. Now they are asking in terms of decibel. Okay. So in terms of decibel, it is going to be 10 log of 4. 10 log of 4 is 20 log 2. That will be 6 decibel. That will be the 6 decibel. Correct answer is option number B. Correct answer, guys, is the option number B, everybody. Right. Correct answer is the option number B, definitely. Yes, guys, so as I told you, whatever content I am discussing will be password protected in a PDF form. You will get it in my Telegram group, gate/ESE by Rakesh Talreja. So yeah, it depends on your motivation, on your attendance level. Today I see a very demotivated type of attendance. Otherwise, questions, so we can discuss even more, guys. Yes. So definitely that interest from the student also has to come up. Otherwise, I am taking the many more questions. Today I see very little less interest in these topics. Okay, so let us stop here, and the password for today is very simple. That is antenna. Simple. The password for today's PDF is the very simple antenna. So you will get both the PDFs, antenna part 1 and part 2, in my Telegram group. This is the password. Please have a note of this. Only the students which are live or which may watch it later on, they will get the password. The gate/ESE by Rakesh Talreja, you can search and you can get my Telegram group. Okay, once again, guys, those who are preparing for GATE, so Mastering GATE Concept series is live. Yeah, you can even suggest to your friends and juniors, okay, where you get the conceptual clarity for the most important concepts. You get the subject in-depth analysis, ki what that subject is and how to prepare. Problem practice along with some previous year question, just to get an idea ki what concept you are studying and what is the problem practice you need to do from here. What type of questions can be expected, and some PYQ also you can get in the class. Followed at the end for the subject by a live Menti quiz to make it a little bit more interactive and fun based. Okay, this is the times. Okay, so since you guys are EC students, so Thursday at 10:30 PM you are having the class Network Theory by your favorite Sanjay Rathi sir. Do not forget to join that. Okay. Okay, workshop, as I already updated in the beginning also, so there is a workshop that is going to be conducted on the app. This is not on the BYJU'S, by your favorite Abhinav Negi sir, who is an IIT Delhi alumni, more than 10 years of experience. He is going to guide you with the strategy, the detailed strategy to conquer GATE 2023. What steps to follow, what not to follow. Join this Sunday, 12:30 PM, 13th of March. Right, and yes, this is once again a reminder from my side. Those who are worried about managing the time for preparing for competitive exam, especially balancing your time with college, you can join me live this Saturday. You can join me live this Saturday, 9:30 PM. Saturday, 9:30 PM. Right. Okay, guys, with this, I, Rakesh Talreja, will sign off. Okay, so in the BARC next class, I think you will have for the EDC, that is again the core subject for EC students, and that will be on Friday and Saturday, that is tomorrow and Saturday at 11 AM. That EDC class will be in the morning hours, Friday and Saturday 11 AM by Sanjay Rathi sir. Join live. Okay, bye bye, thank you, stay safe, take care.